So we'll cover RDD advanced function. As I said, generally we don't need to worry much about RDD, but in some scenarios where you need to deal with RDD and the advanced function, you would know how to use those. We discuss associative property and commutative property. So associative property is associate, like the name itself says associate. How do you associate in mathematics? By putting brackets. So if you associate, so can add or multiply regardless of how the numbers are associated or grouped. By grouped mean how we use parentheses. So associative property is true if putting the association or putting the brackets across any pair results in give the same result. For example, 2 plus 5 in the bracket plus 7 is same as 2 and 5 plus 7 in the bracket. So this is associative. Commutative, name itself says commutative means commute. Commute means moving, like you're commuting from one place to another place. That's moving. So moving means changing the order. So if a function is follows a commutative property, if for example in multiplication, if the numbers are getting multiplied, you change the sequence of order of the numbers, you'll get the same result. 5 to 4 is same as 4, 5, 2. So if any function follow this, changing the sequence of the operators across operation, then the result is same. That means that function is satisfying commutative property. So now, why we not need to know these two properties for some of the RDD advanced functions. So first function is reduce. So reduce function, it works on single RDD. It takes a function which operates on 2 elements, and that function, this function should be both commutative and associative, and it has a new element of the same type. So let's see an example. So I'm parallelizing some data, some numbers from 1 to 20. And I reduce it. What I do is I take 2 parameters. These are 2 parameters. And this is the function which I'm giving. This function is both commutative and associative. So this is the function I'm giving. So all it does is it takes 1 and 2 first, sum it up, then becomes 3. Then it takes 3 plus 3 first becomes 6. Then it takes 6 plus 4, then 10. It takes that 10 plus 5. So that's how it does. It reduces it and you get the sum as 210. How it works? So what I did is to make sure how I print the step in each iteration. So when I invoke the reduce function and pass 2 parameters of, I am invoking reduce function over this RDD only. So this RDD dot reduce and INJ, and I print INJ before the submission happens. So first time it is, taking 1 and 2, and then it's printing 2. In second iteration, this, I is, 1 and 2, it becomes 3, correct? Then it takes 3 and it takes another 3, becomes 6. Then 6 and 4, 10. So it takes 10 and then 5. So like I explained. So that's how it works. A group by key, I think we have seen this. I will be repeating some of the slides, so that
sorry, but I was not able to understand.
You are not able to understand this reduce function.
Yes, reduce.
So reduce is simple. So you have an RDD which consists of these elements, correct? I'm just summing this up in reduce. So in reduce, I'm saying, reduce always takes, 2 parameters, and these 2 parameters are 2 elements from this list. And whatever is function I have, this should be associative and commutative. In this case, I'm just summing it up. So forget this function. If you have to sum this up, one way to do this will be, you will do 1 plus 2, it becomes 3, right? Then take that 3 and then multiply it with add 3 to this, it becomes 6. Then take that 6 and add 4 to it. That's all is happening here. So first it takes 1.
So for each 2 values like I and J, we are reducing it into 1 value and then summing up with the next value.
Exactly. That's what it is. So group by key, we should avoid it, but I think we have seen it earlier. It causes shuffle. In this case, all the records are getting shuffled. And reduce the local, operations happen. Whatever by key operations we are doing, it happens on the local machine. Then shuffle happens. So group by key is discouraged and not performant. Reduce by key is encouraged, and it gives better performance also. There's a fold. It takes function with the same signature. It also takes the 0 value. to be used for the initial call on each partition. Now, what is a zero value? Zero value is the identity element of the operation. That applying it multiple times over the function should not change the value. That's one. For example, you can have 0 for plus. How many times you apply the initial value, which is 0 for plus, the result is not going to change. As for multiplication, it is 1. Any number you have, you multiply it with 1, it doesn't change anything. Return type must be same as input parameters. So that's the property of fold. I will skip this because I have an example here. So you see this same thing. I have integers from I think 1 to 11. So over that integers, I'm applying fold. So now one thing you see, I'm passing an initial value. See, now passing initial value doesn't seem to it doesn't seem, you are not able to think the reason why we need this. In some business scenario, the initial value might be needed. Those might not be exactly mathematical operations or something, but in some business logic or some business implementation you're doing, this might be needed. So you're passing the 0 value, and then it takes, now if you see the difference between the reduce and fold, so you have 1 to 11. So in the reduce, it take 1 and 2 as a first pair, but here it is taking 0 and 1 as a first pair. So it starts from the initial and takes 0 and 1 as a pair, and then it becomes 1. Then it takes that 1 and then another one, 2, that becomes 3, and that's how it adds. Everything is same, only one iteration got added and the initial value got added. So that's a difference between reduce and fold. Another example. So I have this RDD, which is of key value type. So I'm folding it. So how it works, on this is just a plain integer. If I want to make it one key value, so I'm passing fold for, because the key is my string and the value is integer, like there's a pair. So then I'm passing blank string in the fold as initial value for string, and for, because I'm doing some operation right somewhere, so I pass 0 as the initial value for the for the second value of the pair. Then I and j. So all I'm doing is I'm printing I is this, j is this. For example, I is this, j is sales 0. Like initially I'm passing this initial value blank and 0, so it gets blank and 0. Then it takes sales, so it prints that. Now what I'm doing with this is I sum it. This is the some value across departments, so I want to know the value across all departments. So all I'm doing is return type should also be key value here, because input is key value. In the fold you have to have the return type also is key value. So this is what type key I'm putting all, and the value is whatever I'm getting from first pair, take the second element. Can you go on with and whatever I'm getting from second pair, I take the second value of that also. So this is what is happening. So from the I is my first pair, so the second value of the I, and j is my second pair, second value of I. So keep summing it up. So ultimately I get a result which is sum of all this 10 plus 20 plus 10 plus 30 plus 40 plus 50, and I print all as 160. So that's another example how you can use fold. You have foldByKey also. In foldByKey, it should be used where values need to be aggregated based upon the keys. So take this example. It's the same example actually. I have just put it here, but only thing I'm doing is I'm summing it by key only. So sales, so I have different departments, sales, day, production, and I want to sum it by key. So foldByKey, it will take all the pair of which have the sale as key and pass it together. And for each key it is happening separately. So same thing, I'm just printing it and doing the same thing. And you can see for each key, I'm not printing the key. Maybe I should have printed the key also. So, but for each key is happening separately, and summation is happening for each key separately. So this is the result you get. Key is type string and value is type integer. So sales is 40, for production it is 60, and for day it is 60. It's a foldByKey operation. Aggregate. Now you have used reduce and fold. The difference between reduce and fold is they're both same, but in the fold you can pass the initial value. But both reduce and fold have the same return type as your input type. So if your input type is integer, return type will be also integer. If your input type is some tuple with the string key and integer value, your return type should also will be with the string key and integer value. But if you want to change the return type, then you cannot use reduce or fold. Then you have to use aggregate. So here also you pass the initial value. I will see an example. So I have this, I'm parallelizing this sales, dev, same data. Now I'm doing aggregate. So I'm passing the initial value. Now, one thing in the aggregate you remember is, because for performance reason, this key, there might be many records, let's say sales belonging to the same key, sales 10 here and sales 10 here. Let's say both are in the same partition on the same node for that matter. For performance reason, aggregate would want to do the aggregation of these. If these two records exist on the same node, because these two records have the same key, it would want to apply your function, associative and commutative function, on the same node, so that it's like reduceByKey, so that the data transfer is less. And we'll see this with this example. So here I'm passing account and value. This is the input, which is sales and 10. One pair gets passed at a time. Then here, let's go through this. What are the different types, right? You remember this? I'm passing this as a parameter, and I'm doing this account plus value, accumulator plus value underscore 2, then accumulator 1, comma accumulator 2, and accumulator 1 plus accumulator 2. What in reality this is doing is, this code is getting executed on one partition, each partition separately. And what that is doing is, it's just summing up the value. Let's on one partition sales value is there, right? So 10 plus 10 will 10 plus 30 will get summed up, and in 2 iterations. And then that will happen on one partition. Another partition, possibly day values are getting summed up. 20 plus 40 becomes 60. And on third partition, production values are getting summed up. 10 plus 50 becomes 60. So this summing of for each keys on each partition is happening through this function. Now let's say sales value is on some other node also. Right now we have these two sales value which exist on the same node. So this, what I'm saying, will not be valid for this. But let's assume there's another sales key which has sales comma 100, and that sales key exists on some other partition. So now on one partition you have some sales data for 10 and 30, it becomes 40. But on other partition also, on other node also, there's a sales key value, sales data with sales as 60. So across partitions, so this accumulator 1 is for one partition, for example, and the accumulator 2 will be for the same key, accumulation of of the same key on the other node, and it will sum those up. Okay, so I'll explain with an example. Here, no, I don't have example, but I will explain this thing here, right? So you have this accumulator comma value. So this accumulator comma value is input parameters. So accumulator will be 0 for first iteration. Value, the value each tuple in the RDD will be passed one by one in this variable. Correct? So this is accumulator and value. So it will be, because it's key values will be blank and 0, and value will be sales and 10 here. Correct? So and then next time it will be sales and 10 accumulator, and the value will be sales and 30 here. So that's how it works. Accumulator plus value comma value, this 2. This is the function which I am applying over the input parameters which are getting passed to me. What is this? Combining function within partition. So this function is getting executed within each partition separately. So adding the second element, which is the integer, to the accumulator. So all I'm doing here is I'm ignoring the key here completely. Although in the value key is getting passed, but if I say value dot underscore 1, it gives me the key. So I'm not taking that. I'm saying value dot underscore 2. I'm just taking this value because my intention is to sum these up key wise. For sales, I want sum together. For dev, actually for here, I want all sum together, not just sales wise. I want every sum together. So I'm using aggregate for that. So I'm ignoring the key here. So now within each partition is happening. Then after that, across partitions, accumulator comma accumulator 2, it's a merge function which is across partitions. So within one partition you have summed up data for each key, and that happened on all the partitions. Now across partitions you merge the data for the same key 1 is there on partition 1, key 1 is there in partition 2. Now you're using this accumulator from across partitions, you're merging that key 1 data from multiple partitions are coming and getting summed up using this function. So that's how you use aggregate. Aggregate by key is also very similar. It does for the same key. So now I have used the same example, but I have used the, I'm summing it up because I have used key here. So it's same thing is working for each key. So sales is total 40, for production is 60, and for David 60. I will cover only map partition and I will stop there. So map partition, you have gone through, you have written the code multiple times, so you know what map partition is. So it's just a revision for you. It is similar to map, but helps doing heavy initialization once per partitions. So if data is, your data is spread over 10 partitions and each partition has 1,000 records, and you want to, each records needs to refer to database for something, and you need to create database connection. So instead of creating 1,000 times on each node, for 1,000 times on one node, 1,000 data connections on one node, you can, if you use map partition, you can create one data connection and use the same for all the 1,000 records on that node or on that partition. So same thing is happening in all the partitions. So this is where this is how map partition helps. Some initialization you want to do once for each partition. Your partition might have millions of records. You have billions of records you are processing, and that billions of records are spread over multiple partition, and each partition has millions of records. For all the millions of records in one partition, you want to do one initialization. So use map partition for that. I think I have explained this example in the previous slide also. This is one example of map partition. So I'll stop it here. I will quickly, I will stop the recording also. And then